Today I will speak about multi-threading in UI applications. What makes it different from threading in other application kinds like server. I will tell some problems in such multi-threading setups and UI multi-threading, and of course solutions to these problems. So since this is introductory level, introduction to technology level presentation, I don't want to go any deep. So we will cover different approaches, techniques, and threading models from historical to contemporary. And since the last 10 years, I've been developing UI applications. I will tell you the real practical examples and experience of using these approaches. So I hope after this presentation, you will be able to choose. Architecture for your UI applications with multi-threading, multitasking, and multiprocessing. So let's start. And from the beginning, to understand, to choose architecture, we need to understand the requirements to UI applications. And the distinguishable requirement, which is the first requirement and the main requirement, is responsiveness. So I think all of you have seen this picture from time to time. And if you see this picture from one application too often, your heart became full of sorrow. And you shut it down and start to look for alternatives. So what to do? But what is responsiveness? And the answer to this question could be 3 important limits. 50 years ago, Robert Miller, in his historical paper, Response Time in Main Computer and Conversational Transactions, made an assumption that there are 3 important limits in UI UX. So the limit number 1 is 0.1 second. It's the time when if computer reacts less than this time, user feels like this reaction is instant. For example, if you drag and drop some objects on the screen and computer reacts less than 0.1 seconds, you see like it's instant. And since I've been developing IDEs for 10 years, for example, if you type a letter in IDE, the reaction should be less than 0.1 second. The second limit is 1 second. It's so that user flow of thoughts stay uninterrupted. So user understands that there is some operation in background, but he knows that this operation should be finished quickly. So quickly means less than 1 second. For example, in IDE, when you type control with space, completion arises, code completion. So for this code completion, you don't need any progress. You just feel that it should, something is happening, but it must be arise in less than 1 second. And the last limit is, the last limit is 10 seconds. 10 seconds is limit when the something interacts is less than 10 seconds, user keep his attention focused on the task. So for this, from 1 second to 10 seconds, you should show progress. But user will see this progress and will wait. After 10 seconds, he could press Alt-Tab and go to other applications. So from 1 to 10 seconds, you can show progress without persons. And after 10 seconds, you should see how much job was done. So user should expect when this job will be finished. So about progress, here is an example of an indefinite progress. Interesting thing that every activity should be cancelled. Here is an example of modal dialog. So when loading project is ongoing in IntellijIDEA, everything is stopped, so you can type. But you should be able to cancel it. So cancelability is another requirement. But in modern UI application, modal progresses are too heavy. So if you develop something contemporary, all your background activities should be non-modal. It means that this activity goes somewhere, and if you can type anything, you can execute any actions. And here the challenge is that this activity was started for some world, for some state of world which was before. And what should you do when you type some symbols, maybe you should cancel this activity automatically, or restart it, or somehow keep it progress. So this is a challenge. Because and the problem of consistency, because you have two different threads. You have thread that, for example, here is updating indexes or refreshing Gradle project, and the thread when user interact. So the last problem is not so big, and it arises not only in UI applications but in server one, is resource utilization. In fact, it's not very severe. So you can make multitasking on just one. In just one thread, but since now computers are very powerful, it would be cool if, for example, some progress goes not 10 seconds but 1 second, yes, and because of multicore. And also, there are some guys in Backtracker who came and say, okay, why you utilize just one core? I've bought AMD Ryzen for more than $2,000 with 64 cores. Why utilize just one? Are you a developer or not? And you tell, okay, sir, what is your problem? Is it you have freezes or not smooth UI? Oh, no, I have no freezes. No, I have smooth UI. But why do you utilize just one core? And you say, okay, sir, we will try to solve this problem, and you start profiling. So let's see what UI thread is. Basically, a UI thread is a thread with message loop. Message loop is a cycle which take next action from message queue. Here is action constant, and execute this action. So, for example, if we execute action 1, then we execute action 2, and then we execute action 3, and they go in time, they late sequentially. There are, in fact, this is very simple, but in fact there are several tough questions. For example, question number 1. If these actions are finished, in Java, if you know Java, there is some such primitive like swing invoke later. By this invoke later, you put this action in a queue, which is polled in UI thread. So if these actions are finished, it would be not cool that we infinitely looping in this cycle, yes? We need to delegate somehow to operation system or some overseer who will pump other events in UI, like mouse clicks, mouse movements, and typing. So there are different levels of queues. So you pump your queue, but there is a system queue. So you need some primitive here in else to delegate to queue, which is system. The other question is, in fact, this cycle is not while true. It's while not some flag like is shut down is raised. For example, in .NET, sometimes there are such situations in Visual Studio when some thread push action into action queue, but the UI thread is already shut down, so it can't. It really can't execute this action. But this thread, which pushes this action into queue, it waits until this action is done. And since this thread is not background, not daemon thread, your applications can't finish, and it freezes when you close it. Of course, here the answer is to make all threads that you can background or daemon thread. But if you can't make this thread background, you should carefully see the order of termination of these threads, like to see this is shut down flag. So about another interesting detail is pump messages. There is, this is C# code, so in C# there is a possibility to pump messages. This is what I've been talking about this else branch on previous slide, yes? So pump messages will delegate to some system queue and will try to pump messages either from action queue or from system queue. So anywhere when your queue is empty, you can delegate to dispatcher pump message. And interesting detail here that we can pump messages in the somewhere inside processing of action. So here is we process action 1, and inside action 2, after do something 1, we process messages. So action 3, action 4, and so forth will be processed, and then we return to action 2. So it's a kind of parallelism here. which is not non-preemptive parallelism. So usually when you work with parallelism, you think that there is some thread scheduler which stop time slot for your thread and gives this time slot or time slice to other thread. And here you should stop execution of your time slot yourself with these dispatcher pump messages. So it's basically like thread yield. Alexei, do you know how this kind of parallelism is named?
No idea.
It's historically the first one type of parallelism. It's called cooperative.
Cooperative
one. Yes, and it's still used in .NET and Java and everywhere. So when you say, okay, now I stop, let somebody to work.
So does it mean that like some thread directly shows to other thread that I'm ready to collaborate with you?
Yes, but without threads. So it's like multitasking.
Okay.
It's cooperative in multitasking on the same UI thread.
Good.
So here is the interesting detail, and this kind of parallelism here is reentrance. So the stack frame of action 3 and action 4 will be under stack frame of action 2. For example, such reentrancy in ReSharper is .NET IDE is implemented in such a way. We have show progress, and while this progress is not cancelled, we pump messages. While we pump messages, some modules for our projects are loaded. So, for example, pump action 1, pump action 2. And after one module loaded, we can draw progress. So this is some kind of parallelism with such a reentrancy. Although this works, it has some drawbacks. And I want to show you the .NET experience. In .NET, maybe if you work in 19th, you know there is a COM objects, and .NET designed a special approach for COM objects and special threading models. It's called STA thread. STA thread is basically the thread. STA means single-threaded apartment. So object in this single-threaded apartment, it executes its method only on such thread. It means when somebody else try to call your method, it doesn't execute right in your thread frame of, for example, UI thread here. Here, the object belongs to another state thread. So UI thread, when want to call method of object which belong to other state thread, it will serialize it call via message, call method, then execution freezes on UI thread, it goes to execute on another state thread, and then it returns. So it's like message passing. It's some kind of actors before actors became mainstream. And it's still used in .NET and highly used. So the problem here is when you do mutual call, you can receive, let's see, what we can receive here.
Sorry, I missed the...
Okay, so when you do mutual call from these threads, you can receive deadlock because one thread is waiting for another thread. It's quite, yes, it's... You know how .NET solves this question?
I'm from Java world, so probably no.
So
I hope it detects deadlocks, no?
No.
Okay.
In .NET, they think that when they call, when thread is blocked, we need to do pumping. Yes. So, and when you call somebody, you don't just block your thread, you're pumping, and this is some kind of cooperative multitasking. So now two threads can...
Do we need slides on the screen? So if you need slides, just mention it in the broadcast, okay?
Yeah, I need slides, thank you. Okay. Yeah, so here is when two threads call mutually each other, you don't receive any problems, and you just pump with cooperative multitasking, and it looks like here. But other problem, for example, if you have locks and you have such invoke messages in the STA thread, it could easily lead to deadlock. Let me show you. First of all, let some thread acquire a lock, then UI thread goes and it tries to acquire this lock, but it fails. So, but after this, another thread execute method of some object which belongs to UI thread, yes? And it goes there, yeah, and we have deadlock. So what is the solution to this? And guys from Microsoft think that they are genius, and they understood that every failure in acquisition of lock should pump messages. So this is how it works. Now another thread acquire lock, And when UI thread tries to acquire lock, it doesn't block here. It pumps messages. So now another thread calls this method. Its execution is executed on UI thread, and now it returns to another thread. Another thread release lock. Lock is released. And now UI thread can easily take this lock. Okay, everything is good. This is genius solution, yes?
Not sure.
Yeah. In fact, it's not quite. The problems will arise, but the problems will be much deeper and much harder. And nearly, but how it works on a low level. So every monitor.enter, which is acquire lock, goes to wait handle. Wait handle is such an abstraction for every synchronization primitive on .NET. And wait handle goes to some thread local static called synchronization context.wait. On a regular thread, this .wait just waits and nothing happens. But on ST thread, it starts to pump messages. So you can substitute synchronization context as you want. And near a year ago, I found such a strange deadlock. I see that only one thread was deadlocked, and other threads were absolutely free. So this is my original post from Twitter. So I used Microsoft tools. So this is fonts are not very cute.
So what does it mean? It means that the locking system or locking reporting is not very consistent, or?
It means that we have only one thread, which is deadlock, and no other threads.
Okay. Just a bug.
Yes, but no.
Okay.
It's interesting detail. So now you can clearly see that we enter write lock, write lock, then we start to pump, and then we enter read lock. And here in enter read lock is deadlock. It depends. It's reentrancy, but it's not about reentrant read write lock, because usually when you say reentrant read write lock, it's what about? It's you take, for example, write lock, then do something, then you take read lock. Read lock won't be appeared inside a frame of write lock, but this happened inside the method enter write lock. So I tried to emulate it, and I found the problem. So problem is here. Some thread acquire read lock. Now UI thread try to acquire write lock, and it fails, and it starts pumping. Okay, then UI thread release read lock and goes away. Now it's free. But UI thread, when it's pumping and executes some action from message queue, in this action it tries to acquire read lock. And since this read lock is inside method write lock, it thinks that somebody asked for write lock. Somebody. He doesn't detect that it is the same thread asked for this write lock. And of course it deadlocks. So yes, it seems like a bug, but the problem is much deeper. You absolutely can't program thinking about reentrancy and multithreading. This is a bug in core Microsoft library in ReadWriteLock, which I think they didn't. I haven't checked, but I think didn't fix it yet. So this is an exception in core library, and it shows that absolutely you can't think about this reentrancy, because in every lock in your system can start pumping, and this pumping will arise other locks. So ReSharper and Rider experiences say what? So first of all, very hard to develop, assuming reentrancy could be everywhere, very hard. And reentrancy plus multithreading is a pain. Second one, we executed special concepts to prevent this reentrancy. I won't go any deeper in this concept, but it make your multithreading more complex, and for big team, it's harder to understand what's going on. So the hardest bug is related to reentrancy and multithreading. And we spent maybe many months or maybe many years to fix these bugs. So this model problem, as I said before, problem is that this model seems like is broken. Okay, let's go further and let's start about long operations on UI thread. So what means in UI thread that you have UI freeze? Basically, this means that UI thread doesn't pump messages more than 0.1 milliseconds, or 0.2, for example, in ReSharper tooling. So if thread doesn't pump more than 0.5, it means UI freeze. And if you want to split your action into parts. For example, here is an action that process items. For example, loading projects and items are modules which you need to load. Here is items to process. Surely it's not basic array list because we will get concurrent modification exception right here. So what you can do to split this action and not to go to reentrancy, you can do measure start time, and if inside processing we see that start time is current time is more than start time, more than 100 milliseconds, we go to swing invoke later or dispatcher dispatch. So this is a way to put action into the queue. And my action will be splitted so many times that how is needed to process a full queue. But here is a very special case. It's easy to split it because its control flow is implemented like in force cycle of processing. So if you want to split your big method, like do something 1, do something 2, do something 3, into asynchronous world, you can do it via putting the rest of method, for example, do something 2 and do something 3 into swing invoke later or dispatcher dispatch. So put the rest of the method in the queue. So I think this is should be very familiar. It's called callback style of asynchronous development. The problem of this callback style is that it goes to callback hell. So if you do this dispatch a lot in one method, you will go the sequence of curly braces, go to the horizon, and in go to the screen. In JavaScript, you can see such pictures. So current solution, this is historical solution, and current solution in modern world is to use async await keyword. So when you mark your method like async, then after you write await of task yield, it do basically the same what we do when pump messages, but without reentrancy. Yes, compiler rewrites somehow this code, and the rest of method we do something 2 and do something 3 goes to the other frame. So this is a C# code, and basically it's the same in Kotlin. In Kotlin it's even better. You don't have to write await keyword, and they designed a little bit better. So you can see the Roman Yelizarov talk from previous Hydra about coroutines. And this is contemporary way. So Alexey, I have a question for you as a multithreading Java developers. Multithreading Java developer representative. Tell me, please, how Java developers, how they live without async await?
The life is hard.
Okay, I think that's it. So, but I heard that Java received var.
Yeah,
var maybe 2 years ago. Yes,
yeah,
so maybe in 5-10 years they will receive async await.
Okay.
Okay.
Good joke.
Okay, yeah. But they can use Kotlin, you know?
What is Kotlin?
Good joke.
1-1. Okay.
Okay, so but the main of course benefit of asynchronous UI is to extract some EO operations from other threads and from UI thread. And if you work in a web server, for example, Tomcat, you make synchronous request to database, it's okay. Of course, it takes a thread. So for example, you have 200 threads and 200 requests. All thread will be blocked, and it will require a new thread to arise. It's bad, but it's not so bad when you work with UI applications, because you can't block UI thread. So async await is a very good mechanics to unload your UI thread. In fact, here is example with read file async. In contemporary Android, as I know, if you try to make blocking call for network in UI thread, it will show you, it will throw you an exception like networking on UI thread exception. So basically, all I/O operations should be moved from UI thread, and async await is a very good mechanics for this. So let's see the threading models for UI applications. Go further. Currently, you have, even if when we talk about model view controller, model view presenter, or model view view model, you basically have a view which displays UI. You have data for this view, for example, state of checkboxes and so on. And you have big model, underlined model, which is model for application and not for showing UI. And currently, the world have consensus that UI should be single-threaded. Why? Because it's very complex to make it multi-threaded, and it's very complex to make lots of lock. And if one lock asks other lock, you can get deadlock easily because lock order is critical. So it's easily to serialize everything to UI threaded, and in Java it's, for example, Swing, and in .NET it's WPF. Every UI framework now is single-threaded because it's easy, it's easy for big team. So current division is that you should write your view and view model, so data for view, single-threaded, but the big model of application, so any data that will be used to form view model, they could be done multi-threaded. So let's see the threading models world. First threading models, it's not related to UI thread, it's generally. First threading model called shared state. When your thread interacts with some state, and it can mutate or not mutate this state. And the second model called message passing, it's actors, channels between the sectors, and you can see STA threads is also the message passing model. We will speak about shared state. The most important thing you should know about shared state is that shared plus mutable is danger. So this is the reason of data races, and this is the reason of all locking. And this is shared plus mutable is the reason what we will talk about later. So 20 years ago, maybe this was the only choice for big application because it's quite fast. It's faster than message passing, and it's easier for developers' mind, but it brings some problem. Let's start from single thread. We have single thread, and in single thread we have async await world, and it still could be a problem with data consistency. For example, let's say that we have await somewhere here, and we have activity, yellow activity and green activity, and yellow activity mutate shared state set 1, and it after wait it think that the state is still 1, but now new activity came, it set the state number 2, and when we return after wait to the single thread, if there are no multi-threading, only one thread, we return, and our assume was wrong. So now state is 2. Maybe the whole following activity have no sense, and we should cancel it or restart it, and so on. So okay. Let's say we have no async, and let's talk about pessimistic locking. It's very easy. We have one thread, we have second thread, and you don't want to create lots of locks. You just have one big lock for all your model, all your data. So when you modify something, you should modify something under lock. When you access something, you should access something under lock. It's so good, so far so good. It's very consistent model. The only one problem is with this model. Alexey, do you know the problem with global lock model?
I think this very slow.
Yeah, we have, in fact, it's slower than single-threaded. So we have absolutely no, if you have global lock, we have no...
I have an idea.
Yeah.
Let's ask the next question to the Roman, because we seem like to talk to each other. And Roman just like sitting and clicking with his mouse or something. So I think you should involve him to the discussion. Okay.
Next question will be to you, and next one to Roman.
Oh.
Okay. Okay. So if we change this global lock approach to reader writer lock, it will be better. It will make more. So you can see that green lines here. Here is more than red lines. So if green lines are more than red lines, it means that this works better. And now we can take advantage of multi-threading in rewrite lock. The interesting question here is if thread C came and thread C want to ask for read lock. So here's orange for write lock and gray for read lock. C came here and it want to ask for read lock. Should we give here read lock to C1 or no? Oh.
No idea.
Yeah.
Is this question to me?
Yeah. No. Here, a little bit different. Yes. So here we already gave read lock to C1, and A1 is waiting for write lock, and B2 are trying to get read lock. Should we system give read lock to B2 here?
So I don't know the exact answer, but seems like it's maybe some problems with their inverse of priorities or things like that.
There is a problem. It's not inversion. It's not priority inversion. Here the problem is starvation. So if we give the B2 read lock, then A2 can never receive write lock. Yeah, no, because they will switch. The activity of read lock will switch, and they will take read lock, take, and A2 just receive never read lock.
Yeah, but so, from the high, so looks like a priority inversion. Very similar to. Very similar.
The isomorphic.
Okay.
So so here we have some kind of fairness. So when somebody, for example, A2, if it asks for lock read or write before B2, it should receive it before B2. So and now I will tell you about IntellijIDEA and ReSharper threading model. This is it was chosen 20 years ago, and then it was the only choice. It's called ContentModelReadWriteLock. So you have global read-write-lock for all your model, and on UI thread you start, for example, calculate completion. You can code completion. You delegate it to background threads, and when calculate completion is finished, you make an action on UI thread to finish and to show this completion. And if somebody, for example, when we calculate this completion, make write activity, for example, you type a letter on your keyboard, and this should make write activity and write change on global model, it should stop this completion, and it should receive write lock as soon as possible, because as we remember, we have 3 limits, and it should receive its write lock in 0.1 second. So and the last activity should be cancelled. Maybe we could restart it also, and so on. So to receive write lock as soon as possible for write activity, we should put check for interrupt, which check and throw checks in calculate completion. But you see that if we put this check and throw not too often, then this red area is a time of unresponsiveness of UI thread. So this is okay. This works, and it works for 20 years. The problem of this model are following. First one is UI smoothness. So you should to put these checks of check and throw very often. The second one, the second problem is you have lots of code with this check of interrupts because of this, which is not a business logic, just code to check interrupts. The third problem is you can't work with model without read-write-lock or without UI thread, and you have to write lots of assertion in this code, assert read, assert write, and so on. And if you forget to put this assertion, you just receive data erase, and this erase, for example, your test file fail in build server once a day, and it's very hard to diagnose. So, and the last problem is beta intermediate state. So somewhere inside, this is the same problem like it was with single thread deadlock. So somewhere inside write lock, you can write something, and then something will be pumped, and it will change state. And with async await, it's really hard to work with async await in such threading model. So how to diagnose smoothness here? First of all, we make some special assertion. It's called IntellijIDEA and ReSharper that checks that check and throw are less than 100 milliseconds. The second one, when we acquire write lock and it acquires too long, then when read lock, currently read lock, because which is reason why this write lock can be acquired, when it finally release, we log the stack of this read lock to see who is guilty. So the problem is UI thread now do a lot of work. So all write all write activities on UI thread. So UI thread have lots of work, and we need to diagnose that UI thread is don't have too many tasks. So, and how to diagnose consistency in this read-write-lock model? First one is, as I said, lots of assert, like assert that this is UI thread, read, override. There are some static analyzers for this. For example, one of our guy from our St. Petersburg State University, he developed a tool called RacerD with on top of Facebook Infer static analysis engine. This is very cool. You can try it, and it detects data races. Yep. Okay. So what are the improvements for this model you can think about? First improvement everybody think about is to make lock sharding, yes, and make some locks, maybe fine-grained locking. The problem with this model, and with this experience, was this experience in ReSharper. So when somebody make his own read-write-lock for his own subsystem, the problem is, of course, is lock order. So finally, we receive so many deadlocks, so we need to make some watchdog, which in runtime understands that our content model read-write-lock and his subsystem read-write-lock are always taken in some order. And as I know, if you have fine-grained locking system, everybody eventually will make this watchdog everywhere. So this path is very dangerous. The second one is write preference lock, is when somebody wants to ask for write lock, he should be in UI model concept. He should receive write lock as fast as possible. So there are no fairness here. He should receive it as fast as possible. If there are so many tasks on UI thread, because all the write activities UI thread, that UI thread sometimes is very loaded. But some activities in this UI thread, they don't, you don't need it right now. They could be executed later. So you can prioritize tasks for, you can make two priorities, which one that need to be executed right now to show something to user, and one that can be executed when UI thread is idle. The second and the last one, if you want to move some activities, write activities to non-UI thread. And this is how IntellijIDEA did maybe a year ago, so I will tell you later. But now, Alexey, the last question to you, okay? For example, if you have, if we have read lock and we want to upgrade it to write lock, is it possible for read lock to be upgraded to write lock?
To be upgraded?
Yeah, no, you just want to take read lock, then do something, and then say, okay, now I want to take write lock. Is it possible or not?
Probably, I have no idea, but I think they have to deal with their, wait queue or things like that. I think that's not very.
Yeah, in fact, there is a very neat problem. So if you look at the screen, for example, two threads acquire read locks simultaneously, and now thread 1 wants to acquire write lock, and the second one try to acquire write lock, and we get deadlock in this situation. So basically, it's absolutely forbidden. And there is a concept in .NET called and other trading world called upgradable read-write-lock. So we take special upgradable read. It means that if somebody else acquire read, he can execute concurrently. So no matter how much read would be acquired. But if another guy try to acquire upgradable read, he will be blocked.
So is it a kind of compromise between the read? So between the read
it's a kind
and write locks.
It's a special kind of lock when we want to upgrade from read lock to write lock.
So it has some overhead if we compare it with the usual read lock?
Yes, a little bit,
Okay.
overhead. So, but in fact, in such upgradable states, you can easily take write lock. And if you try to acquire write in just regular read, not upgradable one, you will get an exception.
So this upgradable really costs something, correct?
A little bit, yes,
okay.
a little bit. So now I want to ask a question to Roman.
Oh yeah, the first question to
Yeah,
Roman.
so as I know, in Java standard libraries, there are no such things like upgrades in logs. So how Java guys live without such upgradable logs?
Oh, they suffer. I mean, as usual, Java guys suffer. I mean, but fortunately in Java, you have really flexible, I mean, there is a abstract queue synchronizer class. So if you know how to use it, you can actually write yourself an upgradable lock. It's actually kind of a kit of constructing your own locks. I mean, when designing Java, you kind of deemed upgradable locks are to like domain specific, like for things like, you know, like a typical application rarely even needs read-write locks, yet alone upgradable read-write locks. So, but they give you like this abstract queue synchronizer, which is like, you know, like Swiss tool. You can build any kind of log out of it, including upgradable one if you want to.
But abstract queue synchronizers, you know, it's not very easy in use. So
Sure,
that's a special exercise.
You need to have some level, yes, to use it.
Yes,
this is,
yes. And this is public. Yeah.
Okay,
exactly.
So because yesterday I just came to Stack Overflow and asked Java upgradable lock, and there are very, very strange answers to this question. Okay, so and as I
the idea, the most of the classes in Java util concurrent lock, correct? Yeah,
yes.
Good. So they are based on the abstract queue synchronizer. This is a basic framework for all the primitives like Reentrancy like locks and you know any.
By the way, what Java do when you try to when you take read and then go to write, ask to write? Is it exception or just deadlock?
No, just deadlocks. I mean, there's no exception. It will, but Java has deadlock detector built in that you can ask it, and you'll see the deadlock, but there is no exception per se.
Okay, thank you. So as I promised, we're going to IntellijIDEA experience near a year ago. So as I said, IntellijIDEA was developed for 20 years in ReWriteLock paradigm. And near a year ago, one guy, very clever one, tried to move some write actions to non-UI thread via execute write action on this not UI thread. And it took maybe 6 months of work and it failed. So this is not in production right now, and I don't know, will it be in production? The problem is that if you have used this model for many, many years, you have lots of implicit cases when, for example, you have event that reacts to some change. And when it reacts to some change, it goes to swing. And it goes to swing, and and as swing is one-threaded only, it goes and it leads to data races, or sometimes swing have internal locks too. So it leads to deadlocks inside swing. So, and he can't clean all these places, so currently it's not in production. Maybe sometime, maybe in future. Okay.
So now you have, you know, probably half of Swing and AWT team in JetBrains on board. So probably you have much more chances to fix this in Java.
Maybe, but currently, as I said, it failed.
Okay.
Yes, because it's too much legacy in this paradigm. So what's now in 2020 you could use? So other trading models. First one is what used in Microsoft Roslyn called mutable model. So you have some state, and if you want to read the state or modify the state, you make this state copy. In fact, this is copy with star. You see, in fact, nobody make copy. You make copy only when you do write, this copy on write. So, and if we have two parallel activities, like activity A and activity B, they can work on their own copy of this data, do anything they want, and after they do everything they want, if they modify something, they push it via compare and set to the main state. And if state B failed to push it, just it can be cancelled, or it can throw, or it can rebase and try to do again. So activity could be anything. It can be thread, it can be task, it can be graph of task, it can be graph of processes, and so on. And this model, you have no problems here. You have no problems with UI smoothness. You have no problem absolutely with check for interrupts. You can do check for interrupts here, but it's only needed to save the processor, save the CPU utilization. So this model is better in any ways. The only problem in this model is resources, number of resources that you need for this model. So currently in 2020, I think this is mainstream. So mutable models are mainstream because computers have too much operative memory, too much processor, and maybe 20 years ago, no, maybe even now, somebody from tech forums like Hubber writes, "Oh, why this Slack? I don't know. This chat use 1 GB of memory. In my ages, 640 kilobytes was enough, absolutely." And these guys are right. So now they're mostly in embedded, but now the focus is not on resource utilization. The focus is how in big team of developers develop fast, smooth, good, and application without bug, and to do it fastly. Yes, and this immutable model, it helped to do it. And in 2020, you have enough resources. So, and to show you how effective it could be, I will show you what is closer to me is text editor in IDE. So how to represent text editor of 1 megabyte of text. 1 megabyte of text in Java and C#, it's 500 kilobytes of chars, because in Java and C# they still use UTF-16, and I think now C++ developers should laugh a little bit. So we will use blocks, something like B3 to present it. We will use blocks of 2056 bytes, which contains reference and or characters, and it contains reference and also count number of characters in subtree. So this is basically how it looks like. You have only 4 levels to present 1 megabyte string. So now, if you want to change one character, for example, you type something, you create. So you create new node on the last level, new node on the third level, new node on the second level, and new root node. So you have to create around 1 kilobyte of information for one typing, and it's absolutely okay in 2020. This is the way how big text editor is done, and for example, in Clojure, there are lots of such data structures. They're all immutable. Okay, so with immutable, it's everything okay when you have one write, but not a lot of writes and lots of reads, because if you have concurrent writes, only one will be successful, otherwise other one writes will be rollback. So there is such thing like software transactional memory, which is better paradigm. So, for example, if one guy type in one editor, another guy type in other editor of IDE, they do not conflict. Yes, you don't need to roll back these writes. So, software transactional memory is quite simple thing. It's when you have all your memory as database. So, if these activities or transaction intersect in some memory, like here is B, cell B. If they intersect at cell B, then one of transaction is rollback. If they do not intersect at this B, okay, all transactions are committed. So it's much more interesting in case of multi-core development with lots of writes. And I think in 2020, this will be the trend. Software transactional memory will be one of the trends. So all the new UI applications will be developed with similar approaches. But now we talked only about shared state. Let's talk about actor. And actor, you should know that actor is message passing paradigm, when you have one actor could send some message to other actors, and this is a very good paradigm. So actor is some kind of synchronizer. In one thread, maybe it handle all these messages sequentially. They cannot be processed in parallel. So actor is like a lock, so this is isomorphic to lock. So, and when you think about this model, it's very isomorphic to fine-grained locking. So when you have message passing and all your you have only sense, this is okay. But when you need response, like you ask something and need response, this is very, very, very looks like to lots of locks in your system. So And I want to tell you about JetBrains Space Experience, which is another product. It's not. It's a product for collaborative development with web-based UI. So they developed in Actor paradigm for 1 year in small team, and they received such lots of distributed deadlocks on maybe 20 machines, and they cannot debug these deadlocks. They just drop this whole cluster of machines and recreate them because there are no good tools for actors. Actors is hipster technology, you know.
Yeah, ladies and gentlemen, welcome to their distributed world, correct?
Yeah, yeah. So because I heard such a lot of things that actors, yes, actors is a solution, and these guys, whole this year, guys told me this actor is a solution of for our JetBrains Space because it's new. So after the year of development, you can think that these guys are not skilled enough, yes, and they are not very clever enough, but this is the skillest guy I know in JetBrains. And after the year, they...
sometimes problems looks like more clever than very clever guys, you know?
Yes, so absolutely no tooling, absolutely, you can't understand what happens. So after a year, they drop it and switch to plain old SQL.
Oh my God. Okay.
Yes, and now JetBrains Space in the production, and after then they have absolutely no problems with threading after they drop this action. So transactional database, yes, this is a solution. It works very good in the server world with web-based UI when some transaction commit and other can be committed or rollback. And you have what's good in this model? The good is that you have some black box called DB. 100 or maybe 1,000 of man years is spent to use this DB, and you have beautiful, beautiful tooling. You understand everything what happens, and it solves all the threading problems. Of course, there are some problems in database, but there are lots of men, lot of powers of men, lots of development in this. So it's very good. The problem is that the database, classical database, are not very fast. They work on disk. So software transactional memory could be the solution, but in 2017, Intel Optane raised to market. So right now there are such a thing like non-volatile memory, and right now in 2020, non-volatile memory is as fast, nearly as fast as DRAM. So and it costs not a lot of money. So and each year, this non-volatile memory, like Intel Optane, the cost is get lower and lower and lower, and soon they will be in each notebook. So, and I think that we will see in future, we will see some competence approach, and competitor will be software transactional memory for your applications, and just regular transactional database, which is based on this non-volatile memory with all the tooling you have with years of development, because it's very easy. So you just use your ORM from server world and work with objects. That's all. So, but this is the future. And now let's say the most advanced technique, which I want to cover the last one, which how you can do multi-threading, multiprocessing, and so on. And this is called event sourcing, and it's used in some project and some UI projects. The idea is following. You have lots of processes. Here we have only 2 processes, but it could be lots of processes. And you have some event bus, which is basically it's a message queue. So here we have, we are stick to example of IDE development. We have front end, which is showing you UI, and language server, which do something good for your some smart things to your editor add. So they make some events and they put this event in queue, and they have they put this event in the head and read it or pull it from the tail or vice versa. I don't remember exactly. So and this event have some numbers, some information inside, and here is when this front end or server reads these events, they move consequently. They move this pointer and read events, and after after events are read from all parties, you can, for example, delete this event from the system. But in fact, nobody deletes this event. So you have, in big systems, you have gigabytes of such message queues. So this is very, very simple. You have some special God-blessed event queue, which is maybe on some server or maybe on the same machine, on the same process. So how it's used, for example, how it could be used for IDE development. Let me show the example. Suppose we have screen. Screen is on the left. So user type in his front end, he type open curly brace. And since we want to show it instantaneously, he don't know will these curly braces will be accepted by event sourcing or not. I will tell you about accept and reject a little bit further, so not all events are accepted. So this event is going to the screen right now speculatively, and this event is going to the event sourcing. So now we have two pointers of language server front end. So front end and language server, they read this event and they understand, okay, now this event could be accepted. So we commit this opening curly braces. But after then, front end and language server starts to do different things. Front end, if you, for example, user want fastly to type letter, here is letter A, yes? And language server, he understands that if user type open curly braces, he need to substitute close curly braces. So, and I will tell you how we solve the consistency problem here. Maybe you heard about operational transformation and so on, but this is a whole another approach called event sourcing. So these events are going to event sourcing, and event sourcing serialize them in some order. Let's suppose that event sourcing serialize them that curly brace is first. Please see, look at the screen. On the screen, we should draw A, and we should draw speculatively because we don't want to input lock when you type A and you see it on the screen. We draw it, okay. But then front end move his pointer and understand that the next symbol is closing curly braces. So then it takes this closing curly braces, it draw it on the screen, it removes speculation with A from the screen, and now he tried to make this speculation again. So you can see at event sourcing, we have now two A events. First event will be rejected, and the second event is from the next speculation when we retry our A, typing A. So here pointer goes to A, and front end sees that this A from event sourcing, and it rejects it. Why it rejects it? It's an interesting question. For example, we have some, in a very simple case, we have some counter in the program, and it says that this event could be accepted only if counter is equal to this. But in fact, you should be more flexible. It's like in software transactional memory. If you type in one editor and another editor, they could be committed together. So you have some kind of, it's the same like STA or transaction. You say that, for example, this A could be accepted only if this editor was untouched, or this point of some area of editor was untouched. So we reject A, and language server reject A, and now the next A that was pushed from front end, which was retry, it's accepted. Okay, it's accepted, so A became committed here, and the screen looks like here. So this works faster than transactions. So it's called event sourcing, and in fact, it's this consistency called eventual consistency. And this approach is really used in some UI products, and this is maybe one of the futures, of possible futures, and how UI should be programmed in 2020. So thank you very much for watching this video, is I don't know, in record or online, and I hope now you can choose your, now you can wisely choose architecture for your UI application with threading. And we are ready to questions and answers.
Okay,
Thank you very much. Thank you very much. Roman, do we have some questions?
Sure. Yeah, we have some online questions and also some questions that's occurred to me while I was listening to it. So let's start actually from the questions from our listeners. So likely our listeners write lots of mobile applications, and you mentioned a bit, view models and this kind of way to structure your application at the beginning, which is very popular nowadays. And you mentioned that that's all usually tied to UI thread. So the question is, can this architecture be tweaked so that UI model is a view model is moved to background thread instead?
There are lots of approaches to do it, but as I know, there are no one approach in production. This is not successful. So currently, everyone is basically sticked to one thread UI threading. Yep.
What are the reasons?
Okay.
It's much simpler. So for lots of big team of developers, it's much simpler because if you want to do it on several threads, you need to do, if one part of application depends on other part of application of view model, yes, you have to do some kind of locking. If you have some kind of locking, you will get deadlocks.
So we can see in the Java history probably because of Swing is the single threaded.
Yes,
thing.
yes, and
because
VPF
of the
too.
same because of the same reason I think.
But as I said before, Swing has some locks inside, and it deadlocks sometimes when you try to access it from different thread.
So the other question is actually from me. So you've talked a lot about building UI application on one side, which is, like big UI application like IDE, which work with lots of text. Each kind of an extreme case of UI application. Like most people work some simpler applications with small state, and you mentioned that people complain that, oh my god, this simple messaging app takes gigabytes of RAM, which is natural because nowadays we use immutable models, etc., just to make them happen. So the question is, which has occurred to me, that for example, for lots of JetBrains products like IntellijIDEA, people already complain that it takes too much CPU, it takes too much memory, even though it uses this legacy, 20 years old threading model with read-write locks, etc., etc. What would happen if IDE, switches to modern world with immutable model? Which will developers require to have terabytes of RAM on their machines to work with it, or what?
Yeah, that's a very good question. So, in fact, there were experiments with, as I know, with TextEditor, and you can see Visual Studio with Roslyn, which is IDE with immutable model, and it takes lots of RAM. Yes, it takes lots of RAM, much more than IntellijIDEA, but it works and people use it. And currently, I think the problem is in fact, it's easy to buy new RAM to your computer. It's very cheap. It's much cheaper than your development time, because if you take your salary and divide it to minutes when you're waiting and when you're frustrating about freezes in your application, you understand that it's much cheaper to buy.
What about GC overhead for such solutions?
Also GC is very good. Currently in 2020, GC is very good, and Java is ahead of all planet in this. So it works good with this model. In .NET, there are some problems sometimes with GC when too many.
You mean Roslyn, or?
Yeah. There are some problems,
Okay.
But Java is much better.
Good. Do you have any ideas why?
Yes, I have ideas. In fact, the idea is the following. .NET is much more low level constructs like structs, which Java didn't have from the very beginning.
Still, okay.
Yes, so when you program in .NET, you from the very beginning can use structs and pointers and lay your memory to make it optimal. So they don't worry much about garbage collector, and Java have no other way as worry about garbage collector. So in .NET, you understand, they think, okay, they will lay it in structs and so on. In Java, no, they have no way. Then that is why it's better in Java.
So it forces JVM developers to provide more effective garbage collectors, correct?
Yes.
Interesting answer. Okay. Good.
The other question I would might help our readers to understand the context. I mean, again, if you look at applications beyond like simple applications that people are writing, people don't like usually you won't find read-write locks at all, like in a simple application. Like, and you've spent a lot of time explaining read locks a problem with them, so maybe it's worth highlighting, like, why would you even need this? Like me as a, like, you know, I'm writing this simple UI app, you know, I just, you know, put in lock. Why would I ever should be caring about read-write locks, or like, why not just plain locks and live with it?
Absolutely, because I have no idea when I like deal with read-write lock the last time, so probably it's not very common in use primitive, probably.
Yeah, currently, as I said, you can write your own small UI application on single thread. You don't need threading at all. You don't need locks at all. So all async activities could be now, they could be, you can use async keyword and use Kotlin, for example, Kotlin coroutines. So IO activity will be moved from UI thread, and all the long activities from the UI thread, it's, yes, it could be moved to some external process and so on. And you can use, for example, I mentioned the problems with async approach on the single thread. You have consistency problem here, and you can solve it with, for example, I don't know, time indicators like times 1 to 3, and if you see that you came after a wait, you return to the state which was not when you go to a wait, you just drop your activity. So yes, I think this is only for big applications when you have lots of threads and you want to utilize lots of threads and you want these threads to work in parallel. Only then you need to go to read-write-lock, and right now I think you don't need to go to read-write-lock, go to immutable model.
Yeah, so my idea is that usually when we talk about, you know, some concurrency, we talk about some server task probably. And what do they have on the server side? Usually we have the same threads. So the threads do the same, they were similar jobs. So that's why the, you know, common model with a, you know, some read log without dedicated read and write rules is okay. But here we have a model when we have one dedicated thread, I mean UI thread, and all other ones. And probably this is, you know, this is a specific of the domain, and probably these not return, but anyway, any read-write-lock is more useful for this model. So when you have one special thread and n-1 other threads.
So as I said before,
do we need slides on the screen?
Yeah, yes.
Could you please show also slides on the screen? The team?
Mm-hmm.
The team, could you please show slides on the screen? Yeah, thank you.
So in fact, it mostly related to resource utilization, this model of read-write-lock, which is, I said, for UI application is not the main. So the main problem is of course responsiveness, but sometimes you need to extract this long-running activity to some other thread, and it's could be a little bit easier to extract to other thread, to put it to other thread, than to make lots of await thread yield in UI thread when you want to make this long CPU bound activity, but you want to split it to not allow UI freezes and so on. And could be a little bit easier to use read-write locks here. So, but yes, you can, for small UI applications, you don't need this read-write lock model. It's about resource utilization.
Roma, do you have any ideas about for which, you know, patterns read-write locks are good primitive? So we see this situation, we have UI and background threads, and which other you know, type of, you know, domains or you know, utilization is good for using this primitive?
It's actually, ReadWriteLock, you need it when you have really big mutable data structure. I mean, any domain where you have big mutable data structure is where, like, the typical example of ReadWriteLock's usage are databases, because this database is basically a huge, mutable data structure that you work with, and they use ReadWriteLocks a lot. So here, as we saw, big UI apps like IDEA that were developed 20 years ago also represented their the whole state as a big mutable data structure. That's why they need reader locks, because the data is so big. You can't just protect it with simple locks. You have to protect it because it's mutable, but you can use simple locks because that will effectively block everyone. Well, you will not be able to, as we see on the screen, utilize your cores. So as we see in the presentation, the world and discuss, the world is moving to immutable data structure. They use more memory, but solve those problems. So my actually last questions before we close, we still have time, would be, as the world moves, we see more and more even big applications of those immutable data structures, and mutables data used to less extent. Do you think we'll ever get rid of this main thread in UI? Because basically the reason we have main thread in our UIs is because the whole UI is big mutable data structure. Do you think we'll ever have a UI framework that doesn't have the main thread at all?
Sure. I think yes, maybe in future with this immutable data structure, when on languages like Clojure, on languages which do not have mutable data structure almost at all, I think maybe in future we will go to this. Do you think the same?
Maybe we'll see.
Yeah, maybe. Yeah.
Okay. The team shows me like bigger than yours. That means that our time is over. Thank you very much, Roma, and thank you very much, Dima, for the broadcast. I think that's very good beginning. That's very good talk. So probably you show now our attendees see that I'm a stupid guy and you're a clever guy. That's okay. That's what the idea.
No.
Okay. Thank you very much for this. And so, as you probably know, we have Telegram chat for this talk. If you wanted to ask some questions, you can just put the button just under the player and open the link and start some discussion. Also, under the web player, you have a button with the Zoom link. You push the button and you open your Zoom. And now go to the discussion, and you can go to join to discussion zone with Roman and Dima, and you can just ask some question verbally. That's very good. So what else? What do you think about the first? This is opening talk. Mm-hmm. So what is a good idea for us to start with such kind of talk? What do you mean? So is it, how you can mention, is it a low level or high level or overview or smoothie?
For my level, I think it's smoothie.
Smoothie.
Yeah. Do you think the same?
I can't say that I was totally involved because I want to make some troubleshooting during the talk, and this is why I missed some of your questions. Sorry for this. Roman, what do you think about the complexity, the level?
I think for the conference like Hydra, that was kind of a smooth introductory talk, because usually there are lots of Hydra conference is kind of usually it combines also lots of scientific talks. This is more like good technology overview, like real world. But for some people who are not writing UIs, that may be something new, because this is really interesting domain. It's really
10 seconds
specific part of the concurrent programming, writing UIs.
Okay,
really...
thank you very much. Thank you very much, guys, and see you in Zoom in 30 seconds. So
thank you.
Yeah, see you a bit later. Bye.